All right, so in 4.6, we talk about these things called imaginary numbers. So basically, what we have here is a number system. All the numbers that we've been using up until right now, today, have been called the real numbers. The real numbers. And those are numbers that we've gotten along with fine. And we're very, very useful. We have rational numbers, irrational numbers, everything in between. But now we have a totally different number system that exists that we just haven't used before, or we've run into situations where we've just ignored the number because we didn't know what to do with it. So there's these things called complex numbers, and inside there are these imaginary numbers. And so an example of this is if you get the square root of like a negative number, square root of -4, that's an imaginary number. And if you plug that into your calculator, it's not going to give you an answer. Each calculator will give you maybe a different type of error message. Mine gives me, it's a non-real answer. It says error, so it's a non-real answer. So it's in a different number system, and we have to figure out, well, is that number useful, or how do we even use that number? Okay, so we have the imaginary unit. The next thing I want you to write down is a complex number. Complex number is written in this form right here, a plus bi, where a is the real number part and b times I is the imaginary part. So for example, you're going to see these numbers that look like 5 plus, and then you'll have some imaginary unit connected to it, like 3i. And so again, we'll talk more and more about that I unit. And then an imaginary number is a complex number where b is not 0. So if you look at this, it's a complex number, but basically where you have an I term in it. So long as you have a square root of a negative number in there, or so long as you have some kind of I in your expression representing a value, it's an imaginary number. So just think I means imaginary. If you see the I, you have an imaginary number. All right, so let's look at example 1, which is an equation, and this is going to look very similar to 4.5. We're going to solve for this quadratic, and notice that there's no b term here, so it looks like we'll be able to take like a square root. So we'll go ahead and subtract 18 here, and get 2x squared equals -90. This is a squared term. I'm going to get the squared term by itself. So now I have x squared equals -45. And now I take a square root to solve. And I'm going to get x equals plus or minus the square root of -45. And so we basically did the same exact thing in 4.5. We solved it. But now we have a different type of answer. We have the square root of -45, which if we try to approximate that in our calculator, we are going to get an error. It's not a number that we can make sense of yet. It's an imaginary number. It's not a real number. So what we're going to do is, instead of just ignoring these types of numbers, we're going to use some notation to write these imaginary numbers. And all we're going to talk about here is that we're going to make one substitution. The one substitution here is that the I, we're going to make a substitution that I equals the square root of -1. Remember, this is the imaginary unit. Okay, so this is my answer right here, but I'm going to go ahead and reduce this and make it look nice. And here's how it would go. I'm going to say that this is equal to x equals plus or minus, and now I'm going to try to, again, break up that -45, the square root of -45, into different parts. The first thing I'm going to do is take out the -1, right? I'm going to separate that -1 out because that's the imaginary unit. So I take root -45 and simply just kind of break it up as the square root of -1 times the square root of 45, right? So this would become this right here is now I, so I'm going to write this as I times root 45. So the only thing we're doing here is dealing with that square root of a negative just by making a quick substitution and writing this in some kind of standardized way. So we're not done yet, because in 4.5 we took the square root of 45 and we reduced that further because there are perfect squares in that. So we keep going here. We're going to say that this is equal to I times, now root 45, I know that I could break that up into 9 and 5. And so this would become x equals plus or minus I, and then the square root of 9 is 3. So this would be times 3, and then root 5 will just stay as root 5. So my answer here, written in a nice way, would be x equals plus or minus. Now with this right here, I have I times 3 times root 5. I'm going to write this as 3I times root 5. So plus or minus 3I times root 5. And really what that's saying is that I have two answers that would satisfy this equation. 3I root 5 and negative 3I root 5. And these numbers are not real numbers. I can't plug them in to get an actual decimal because it'll give me an error. But these are the answers, and they do have a place in the problems we're trying to solve. They are still very important. All right, so with that in mind, I want you to try to just practice that reducing of these square roots. So here's some practice problems. All I want you to do is simplify each radical expression and make sure you express your answer in terms of I. So if you want to pause the video and try some of these, and then we'll go through it. So part A, so root negative 60. I'm going to break that up into, first I'm going to break it up, I'm going to take that negative 1 out because that's going to basically be my I term. I know this is an imaginary number. And then I'm going to say, all right, 60 perfect squares that can go into 60. Or again, you could do the factor tree. I know that, let's see here, 4 times 15, right? 4 times 15, so 4 times 15. So I'm basically breaking up negative 60 into negative 1 times 4 times 15. So I'm doing that because I know the square root of negative 1 is equal to just I. And then I know that the square root of 4, I know is 2. And I know root 15, well, that doesn't change because root 15, there is no perfect squares in there. And so if I multiply all these back up, I would simply write my answer in a nice way as 2I root 15, and that would be a common way to write this. This is an imaginary number. All right, E. So here I have negative 5 just outside of the radical to begin with, and then I'm going to start breaking up root negative 200. So I would break this up into, first of all, negative 1, and then 200, just like 4.5. How do we reduce that? I know that 100 times 2 is 200, and 100 is a perfect square. So now I have this and this are going to give me, this is going to become I, and root 100 is 10. The rest of it I'm going to bring down. I have negative 5 that was just sitting out there before, and I have the square root of 2, which is just stuck in. So when I put all this together, I would just kind of multiply things that I can multiply and rearrange these terms. So you can see I have a negative 5 and a 10 here times 10. So I'll just put those together. I can multiply that to negative 50. And then I have an I term here. And then I have a root 2 as well. This would be a little bit nicer way to write it. And that would be part E. Now looking at part F, how would we reduce this? This is a case where I probably first would combine this into 1 and then break it up again. So what I'd probably do here is take all of this and multiply it together, the things that I could multiply. So I would take the 3 times the 10, and that would give me a 30. And then I would take my radicals here, which are root negative 5 times root 8. And that would be the square root of negative 40. So I might start like that just to put it together. And then I would try to reduce this or reduce that radical as much as possible. So I know that the square root of negative 40, I first can take out that root negative 1. That's going to be my I. And then 40, if you think about perfect squares, well, 4 times 10 definitely goes in there. So I'm going to start there. The square root of 4 I know is 2. I know that this thing right here becomes an I. And everything else is just going to come below. So 30 times that. This root 10 is just going to stay there. And then I'm going to write my answer here as, 30 times 2 is 60. And that would be I. That I term is still in there. And then times root 10. And there would be my final polished up answer. All right, so I want you to practice this problem as well. So this is like the first example that we did. Solve this equation, and then put your answer in simplest radical form like we did in 4.5. So again, if you want to pause and try, go ahead and do that. So here it goes. So if we're going to get x squared by itself, I'm just simply going to get that, subtract 28 on both sides. And I'll get x squared equals negative 50. Then I'm going to take a square root of both sides. So I get x equals, now this is plus or minus root negative 50. And now we're at that stage that we did those previous problems where we want to put this into a reduced, simplest radical form. So now we go ahead and we notice that we have a square root of a negative. That's telling me that this number, this value that we have, is an imaginary number. So I'm going to write this as root negative 1, pull that off separately from the real number part, and then now I think about root 50, and of course root 50 could be 25 times 2. And so now I can take these little bits and pieces. I know that root negative 1 is going to be I, root 25 is going to be 5, and then root 2 is just root 2. And I still have my plus or minus here, notice. My final answer here would be plus or minus, and then I would just, out of convention here, I would just take the I and the 5 and just write this as 5I root 2. So there is my answer. There are two answers here. One of them's positive 5I root 2. The other one's negative 5I root 2.